Hello and welcome to the Unit 1 Part 1 test review. I'm your host, Mr. Williams. Let's get started. In this unit, we've been focusing on energy as it pertains to charges and electricity. What we've learned is that there are two different charges, right? We have a negative charge, and we have a positive charge. We draw them like this. Positive and negative charges are attracted to each other. So these want to be together. Like charges repel one another, so they want to push apart. When we say that they want to push apart, that's because when these like charges are together, they have what we call potential energy. So while they're close, they have higher potential energy. When they're further apart, they have low potential energy. But when we have opposites, when they're together, they have low potential energy, and when they're apart, they have high potential energy. So we also have two types of energy. Let's talk about that. Let's start with a new fresh board. We have two types of energy. We have potential energy, and we have kinetic energy. This is energy that is stored. Kinetic energy is the energy of motion. Things that are moving. This is energy that moves. Some examples of potential energy are going to be our electrical potential. We're going to focus on this one a lot, or I guess we have focused on this one a lot. We have chemical energy, energy that's stored in the bonds of molecules. We have nuclear energy, stored in the nucleus of atoms. And then kinetic energy, this is moving energy, so we have motion energy, heat energy, light energy, sound energy, and also electrical energy that's not being stored. So energy that's being, I guess, used is electrical kinetic. Okay? Let's talk about what is this electrical energy. So electricity, let's use a different color. Let's see how this red works. This red works wonderful. Electricity is the flow of electrons. What's an electron? You're probably asking yourself that. I've probably told you, who knows? Or you learned it from Miss Littrell. I'm going to tell you again, in case I forgot, in case you haven't learned it. Electrons are negatively charged particles. Okay? So, when we draw this, that's an electron. It has a negative charge. So electricity is just the movement of these negative charges. So when we have electrical potential energy, we have a collection of these that aren't moving. When we have electrical kinetic energy, these are moving. We also learned that energy can change between types. We cannot create it or destroy it, but it can change between all of its various forms. Specifically, we've seen potential being converted into kinetic, and also kinetic being converted into potential. For example, in a simulation, we saw that if we put two negative charges together, this has high potential energy. I'm gonna call it PE, and I'm gonna call kinetic energy KE. So we have high potential energy, and then when you would press play, these would, they'd move apart from one another and turn the potential energy into kinetic while they moved. So if they're moving, it's kinetic. If they're staying together, that's potential. We saw this in the Van de Graaff generator. We saw that what happens on this thing is that it starts to build up charges, and it builds up potential energy. When we put the pipe hands on it, these charges also, I should have used a different color. These charges also built up on these pipe hands, but these pipe hands were light. So when we had enough of these charges, they pushed against each other, turning their potential energy into kinetic. So that's why they flew off of the machine. When we have a bunch of these, let me erase the pipe hands here. When we have a bunch of charges in the same place, that's called an electrical field. Let's write that down. So an electrical field is just a collection of those electrons, of those negative charges. And the more of the negative charges meant that it had more potential energy. And the closer they were together, also meant more potential energy. So as these built up, they get closer and closer because they're coming from the cord that plugged into the wall. So that's where the electricity is coming from. And it's going up the machine, and they're getting deposited on the globe at the top. So as they build up, they want to leave. So we build up an electrical field, just this collection of electrons. We have more of them, so we're building up more potential energy. And as we get more in this smaller space, they get closer, also creating more potential energy. Then when something else gets close enough, like the pie pan, it's a rectangle, call it a pie pan. These electrons, if you'll remember from the first simulation, that a charged particle is lightly attracted to a neutral. And so if this is neutral, these would like to be here. And so if there's enough and the field is strong enough, these actually jump from one place to another, and that's the spark that you saw. So the spark is the change from PE to KE. So that's the kinetic energy. The spark is light. Now in the burning bubbles, let me get rid of this. Let's restart our thinking here. In the case of the burning bubbles, we weren't using this, right? So let's block this off. We're gonna save this. Okay. In the burning bubbles, we have methane gas, right? So we've got a Bunsen burner. Let's see if I can draw one of these. And it puts out this methane gas. Okay? You're just going to have to believe me that that's methane, because it is. That's why you need to believe me. So we see that there wasn't a Bunsen burner in the... Okay, I am slightly delusional here. I thought I knew what I was doing, but here we are, deep in the video. All right, so we had these bubbles, right? And they had methane gas, right? Now, this, I'm just gonna reshape this bubble to fit that better. Okay, it's got millions of these methane molecules in the bubble. Okay, now, there is stored chemical energy in here. So we have, at the beginning, we have chemical potential energy, right? Now we also have this candle that was on a stick. It was on a stick because those bubbles are very hot, because, well, the bubbles themselves are not hot. They're hot when it burns. So that's what we're trying to explain right now, right? So we have, you know, a little flame boy here. And so we've got this, it's burning. It's got, this has heat, kinetic energy, and it's got light. It doesn't do a whole lot, but it is glowing. But this heat provides energy needed to break bonds. So, keep using different markers. It looks more presentable. So the candle provides energy to break bonds. Now, when these do break, so we've got energy, it's going to break these bonds. Now, we can't just have these atoms floating around. They don't do that. It's very unstable, and so they would like to be stable, so they're going to, when they break, they're going to react with the oxygen. This is oxygen. I'm going to go ahead and put the lone pairs on there. We'll talk about those later. So this is oxygen that's in the air, right? Now, so we have this oxygen, we have this, I probably need more, or do I need 2 oxygen? Yeah, I need 2 oxygen, I think, and 1 CO2, or one, okay. So it breaks the bonds. So that takes energy. Now, when it releases energy, that's when they catch on fire. So the fire is caused by, we'll write fire in red. So the fire caused by forming new bonds. Oh gosh, I wrote it right over there. So forming new bonds and releasing energy. Okay, so these break. These also have to break, and all that's from here. So this breaks the bonds, and then when we see the fireball, you know, once it's all on fire, so we've broken all the bonds in place there, it's just a giant fireball. And what's happening is that we're making CO2. I'm just going to write that, you guys are probably more familiar with that. And then we make 2 water molecules. Now, not just 2, millions. Because this is happening a whole lot. That's why we see it. You can't actually see like the individual atoms, but we can see all of them reacting into this fireball. And so when that forms, it releases, just like the candle, heat and light. The heat is very hot. But it's not the reason that the fire alarm went off. Okay, that was like 15 to 20 minutes after we were done filming that video. That was not our fault. Never has been. Let me see. I think that is all that I have. If you have questions, please ask your teacher, whether that be me or Miss Littrell. That's our job. We're here to help you. Message us on Canvas. Email us. Set up a Google Meet where we can explain all this stuff to you. I'll be more than happy to do this in a way that's less confusing in the way that I just did this. Anyway, have fun studying for your test and good luck. You guys will do great. I believe in you. Take care.